Thanks, Chip. So we're going to keep things moving, and I'm going to introduce the next guest or the next speaker, who's going to talk to us today regarding the actual solutions that we currently have out there today. As we've mentioned over the course of the morning, there's some great pieces regarding the narrative on paper, and the slides that you've seen this morning is great. It's fabulous. They're good take-home research pieces that I know you're going to look at. But we got to try to apply it. We have a bunch of puzzle pieces that we need to put together. They're open. They're multi-vendor. They function in different ways. The question is, how do we put these pieces together? And we want to use this opportunity to give you a starting point in doing just that. So I'd like to introduce Mr. Steve Wallo, who's our Chief Solutions Architect for Brocade. He is also the primary contributor as far as architecture and design to the Tech Pavilion. And he's going to come up and talk to you today about the solutions that are out there, how they're brought together, what pieces that are used, and really the value that each of the individual solutions brings to the overall conversation regarding the new IP, some of the modernization efforts that we've been talking about over the course of the morning. So with that, I'd like to introduce Mr. Wallo.
All right, thank you. So let me ask, how many people have seen the Tech Pavilion so far? Oh, wow. Is anybody else going to go twice? All right, cool, okay. If you're Brocade, you're not allowed to say that. So here's what I'm going to do. I'm going to talk to you about what we've done out here, the reason we put it together, and then we're going to walk through the solutions. So there's 11 solutions. I'll talk to you about what those are at a high level, and then if you haven't been out there, please go check it out. That picture, there's a story behind that picture. So they asked at the last minute, they said, hey, can you give me a picture? And, I don't have the photography skills to do anything but grab the flag from my porch and sit in my dining room and take a picture. So we're going to have to change that. Anyway, so I'm the Chief Solutions Architect for Brocade Fed. The idea behind the Pavilion is that we wanted to show solutions that were applicable to what you guys were interested in. We didn't want to show products. The idea is not to show products, right? We don't want to say, hey, look at this new box. It's got 10 ports instead of 5 ports, or 20 ports instead of 15, right? That's not the idea behind the Technology Pavilion. So minimal product, and then we also want to make sure that we're doing it based on a solution. So we're not going to show you the product, but we're not going to show you the capabilities. We're going to put it inside a scenario that you might see in the real world, and we'll walk through what those scenarios are. And each one is different. Some are related to SDN, some are related to IP extension, some are related to storage extension. We have things related to security. All right, so a lot of the buzzwords that you see in the federal space, right? Security, cloud bursting, all those things. Hopefully you'll get that feel from what you're going to see next door. Okay, so that's the plan. Okay, here we go. So the first one that we're going to talk about, this is the high-performance network encryption. Now, security is a big thing, right? For those that might have worked in the federal government, like myself, for a long time, people are hacking stuff left and right. This solution is not about data at rest, right? This solution is about encrypting the data as it moves. So if you're familiar with things like MACsec or IPsec or Type 1 encryptors and the whole idea behind encrypting data as it moves between things, that's what this solution is going to show you. So when you go out there, you're going to see the ability for us to demonstrate from a wiring closet perspective, so the very entry point of your network, up to your core, so that's extension piece using MACsec, and then long distances. If you want to see, hey, how do I encrypt data from Atlanta to Florida, from Florida to Chicago, over to California, that's what we're going to show you. And we're also going to show it to you at 100 gig. So this is high-performance security in flight. That's what this demonstration is going to be showing you. Now, one thing about doing encryption is it's kind of hard to show, right? You kind of got to take it on faith. I can say, yeah, I'm encrypting the data in flight. And people go, well, I really can't see it because it's encrypted, so what do we do? How do we get it so that you don't have to take it on faith? So what we've done is we've built this platform to move a lot of data, and then we took a snapshot of it with a tap. And so you guys are familiar with taps. You just, here's the line, and you kind of plug in this little guy that monitors on the side, and we bring that tap, and we're running a video stream across it, and we'll show you, hey, here's a video that you can see. And then we'll turn the encryption on, and what happens to the video? It goes away. Right? It's a very simple demonstration, but it gives you that thing where you don't have to take it on faith. Right? So high-speed network encryption, 100 gig, IPsec, MACsec, and then a demonstration of, I can actually see it, or no, I can't. Okay? That's the first one. Now, one thing about this is, if you guys are familiar with commercial solutions for classified, in the old days, in the old days. It's like today, right? In the old days, you had to use type 1 encryptors to encrypt data at higher classification levels. If you guys are familiar with secret, top secret, stuff like that, right? There's a new standard that came out that said, hey, you can use commercial products if you double encrypt. And oh, by the way, you double encrypt with something called Suite B, which is another algorithm associated with encryption. So what we have also done is we've shown you some of these solutions that we're double encrypting things. We're using TLS, we're using IPsec Suite B, we're using different things that allow us to meet this requirement so you as consumers can say, hey, I don't have to spend all this money on these type 1 encryptors. Hopefully nobody sells these in the room because that would be bad. But you don't have to go down that path anymore. You can use stuff from vendors, whether it's us or somebody else, to meet this requirement, right? That's the point of the demo. Any questions on the first one? Cool. Right, let's go to the second one. So Chip talked about IP storage extension and the need for dedicated networks. One thing that everybody's asking for is how do I get information from one data center to another data center securely? Or, what's happening now is people are consolidating data centers. There's no 600-700 data centers anymore. Maybe there's 40 or 50, right? People are trying to consolidate down. When you do that, the information between them gets a lot more powerful. You get a lot more bandwidth moving between data centers. So what we're going to do is we're going to show you a solution that takes that information, gives a high bandwidth profile behind it, and allows you to move information back and forth. Now that's all well and good, but what's really unique about it is a couple things. First, I can show you how to move data back and forth, no problem. But if you lose visibility into what's moving around inside that tunnel, if something goes wrong, what do you do? Right? Who do you call? So one of the most important things that we found in all these solutions, because we have to build them ourselves, is if it's not working, where do I look? How do I troubleshoot this, right? So we're going to give you and we're going to show you the ability to have visibility into the flows moving across that path, right? So this just isn't moving data, it's getting information about what the heck is going on inside there. And we're going to show that to you so that you can see, hey, this is something unique, or that's a problem, that's where I need to look when something hits the fan, all right? The other unique thing about this, I'm going to hit one or two for each one of these, is that, one, it does fiber channel and IP at the same time, right? So this is one of the only solutions that does, WAN optimization, IPsec, has all these cool things behind it, a lot of proxying, but it does it for any type of storage that you have. So you don't have to stick with just fiber channel anymore. You can do IP storage, still use this product. The other one is, it has this unique failover mechanism, and this is one of the first things to have that. So the concept is, if I'm going to talk to you, and we set up a tunnel, a path, right? In the real world, you want to have multiple ways to get there. So that if my one circuit goes down, maybe I have another path, right? I want to have mission criticalness to this thing. So we've set up multiple what we call circuits. They're just multiple ways to talk to somebody. In the past, if one of those circuits went down, whatever information was flowing through that pipe, what happened to it? It's gone. You lost it, right? Now what we're going to do is we're going to hold on to that. We're going to put it in cache. And until we get an acknowledgement that the other side got the data, we won't release it from cache. Which means I can take one of the two circuits and I can hack it, and you'll see the information that was in the pipe get released from cache, moved over to the other circuit, and brought back down. So this gives you the ability to have high-speed data move and have that mission-critical nature related to what you want for your business. Make sense? Cool. Any questions on this one? All right. So let's move along. So the cloud access. Which one is this? Open standards across the enterprise. So anybody know what the term 802.1BR is? Anybody heard that term before? Anybody heard the term stacking? Right? Stacking. Yeah, there you go. So stacking is about taking information or taking switches, you put them in a wiring closet, and you can take a stack of 8 switches, and you use a cable about this long, and you connect them together, and you manage it as one device. It's kind of cool, right? But the problem is you're limited to that one wiring closet, and you're also limited to the feature set of each one of those boxes. If you want routing or you want some advanced feature, you got to have every one of those boxes inside that wiring closet has to have that. So we're doing two things here. One, we're showing you 802.1BR, big techie term, but all that means is now I can take a stack long distance. Right? If you've walked around the show and you visited some of the sponsors, and hopefully you did, you might see these little, you might see the Google commercial with the little flying robots that are delivering packages, right? Those little things. You might see something like that that's sitting on top of a sponsor table. That's a camera. And what we've done is we've taken 8 switches and we spread them across the showroom floor, and we've attached a live video camera that we're bringing back to a central location to show you that, yeah, I can build a stack that you can manage as one piece outside of the 1 meter, 2 meter cable length. And it is using open standards, that 802.1BR. So that's the first thing. The second thing is we've used different flavors of devices inside the stack. So if I want advanced features, let's say I have an 8-member stack. If I want advanced features, the best way to do it is to have one or two, because you want resiliency, of those boxes to be the expensive ones, right? And I probably shouldn't say things about price because I do work for Brocade. But those are the expensive boxes. Then maybe the other ones could be cheaper boxes. Yeah, but then I lose the advanced features on the cheaper boxes. Not necessarily. What we're doing is we're doing something called hyper-edge stuff. What that means is I'm going to take the advanced features on the top boxes, and the bottom boxes will inherit and use those without having to pay the price point for the stuff on the top. Make sense? Okay, so long-distance stacking and the ability to inherit all these really cool things to some of the cheaper products below that allows you to grow and scale, right? So that is the integrated cloud access, and we say cloud because you can pretty much use your enterprise to get out to the cloud, right? This is kind of almost buzzword bingo for federal. Right, the next one's pretty neat. So software-driven security, I'll read the title here, simplified threat detection and mitigation. Chip talked a lot about automation, right? This is the SDN play. This is software-defined networking. If you guys, I'm sure everybody knows about software-defined networking, right? One of the key, it's really two buckets. It's network function virtualization. I'm going to take a hardware switch, and I'm going to virtualize it and put it on a VM and be able to use it in a piece of software, right? The other side is I want to take the control of the switch, right? Normally you write commands to the switch, and then once it sees a command, it moves the data, right? There's a control part and a data movement part. We're going to take the control part, and we're going to remove it, and we're going to centralize it, and just let the switches move data, right? That's the other bucket of SDN. What happens here, when you do that, it allows you to centralize policies. And what we're going to show you is a threat that comes in. We have an application that's monitoring it. Now, here's what happens. If I have centralized policies, who makes the decision? Is it just one guy that goes back to that central controller and programs the same thing? No. You don't want that. You want the decisions to be made by something else. A feedback mechanism, something that's monitoring your network or your applications. So you're making a decision on what actually your infrastructure needs. That's the best way, right? You want this feedback loop. So we have an application that runs out there that monitors the network, and it's monitoring it for threats. Malformed HTTP request, denial of service, all these funny threats that are happening in the real world. And it's automated, so it's constantly monitoring it for those threats. Here's what we do. We launch a denial of service attack. Has anybody ever heard of a piece of software called the Low Orbit Ion Cannon? Any hackers in here? Yeah, some people are shaking their heads. We actually downloaded that thing on our corporate machines and use it because it simulates a real-world attack, right? It's what these guys use. So we take that low orbit ion cannon and we generate different attack vectors against some gear. And then this application that sits out there is monitoring those signatures, and when it sees something it doesn't like, it does two things. One, it mitigates it. It drops it in the bit bucket. It's gone, right? Your denial of service is gone. You can do that in the past. You can do that with different products, right? But what we also do is we make a copy of it. And the reason we make a copy is so that we can send it to a bank of analytics stations or analysts to figure out where this is coming from, right? If China hacked us, I want to know that it's China. I want to know where it is, and I want to honeypot them so they don't know that I'm looking, right? This particular piece of software does all that for you. It automates the process of mitigating the attack and then moving it somewhere else so that you can actually see what the heck is going on. Make sense? Cool. All right. Next one here. There we go. Okay. So we're going to move up a little bit. This is the OpenStack. So if you guys aren't familiar with OpenStack, so we talked about SDN being this centralized point, right? And it's controlling what? It's controlling the network. Well, what controls the servers or what controls the storage, right? I can do SDN and I can talk to the network, but there's other parts of the environment, right? If the application's running slow, maybe I need to do something with the application. Maybe I need to add more resources behind it, or maybe I need to add more storage or do something to the network, right? If I talk just SDN, it just talks to the network. So I have to have something that sees the rest of the enterprise that sits at a higher level to be able to see that and be able to make decisions on what's happening. OpenStack is one of the open standard versions of that. This is a high-level orchestration piece of software. What it does is it has visibility into everything inside your environment. Servers, storage, networking. And we're trying to automate this process. So what we do is we fire up an OpenStack instance, and we're able to go in there and say, okay, these are the resources that I have. This is the information that's flowing. If I need more, and Doug will show you if you go see it, OpenStack has a plugin for each one of these, right? And you put these plugins in there, and then it can tell the servers, please fire up more virtual machines. And oh, by the way, please adjust the network in the middle to accommodate that, maybe different VLANs. And then on the other side, hey, I might need some LUNs, right? If I'm firing up virtual machines, they need some data stores, so it'll actually go down there and it will talk to the controllers and provision more LUNs. So you're tweaking the whole environment, right? Now, if anybody knows Fiber Channel on the back end, if a virtual machine needs to talk to a SAN storage device, what happens? They got to be zoned. Right? So the last thing we do is we automate the process of creating that zone, linking things together on the other side. So this is a demonstration where we're able to tune the environment based on what an application needs the whole way across all the vertical structures and then tie it all together on the back end and automate the whole thing. Right? That's the OpenStack demo. That one's actually pretty cool. Okay, so now we're moving into the tactical pieces. So this advanced mobile tactical analytics, improved scalability. So this is the analytics stuff. Brocade bought a company called VistaPoint about, I don't know, a year ago, right? Yeah, somebody might know, aside from me. The company makes really, really good analytics stuff for LTE networks. Like, hundreds of thousands of subscribers, the AT&Ts, the Verizons of the world, all over the world. Great analytics stuff. A lot of our customers in the DoD, Intel space, need tactical analytics for their remote mobile pieces. You see the guys in the fields with the armbands running around in Afghanistan. Things are LTE. They're connected together. That's a great way to do that. We can use now VistaPoint to give you information to what happens. Where is this guy? Who's he talking to? How's his quality of service? Every part of the cell tower we've actually put out here. In fact, if you look on the table, you'll see these big white fin-looking things. We didn't steal those things. They're actually from a cell tower that we got from General Dynamics. But the bottom line is we actually have an LTE network running over here. Hopefully it's not blowing up anybody's phones, right? But it's out there. It's running. It's real world. In fact, we have phones generating the data to represent a tactical LTE network. And then we use VistaPoint to give you information to what's happening throughout that process. So if there is a problem in a tactical space related to LTE, VistaPoint can show it to you. It's pretty cool. There's a lot of nice little toys behind it. All right, so definitely go check that one out. Any questions on those two? Okay. Yeah, I'm explaining it really well, or it's almost lunch. Okay, so come down to the home stretch here. Traffic management, provisioning, simplified through SDN, right? The whole idea behind this, and this is something that we've had running for a while, is we're trying to show you how we're automating the ability to move flows and information around in a network. We have a little iPad that allows you to manipulate open flow rules. That's the mechanism that allows you to do that SDN kind of thing, right? We're showing people how to take information, and if there's congestion or there's something else going on, to say, you know what, if that guy's talking to this guy, please move him over because there's congestion. Prioritize what's happening. Maybe this is based on a policy. The other one is this thing called EMS. Right? Some kind of provisioning, enterprise management services. But it's related to, remember we talked about SDN, we said there were two buckets. Right? There's the programmability, the data, and the control that we separated. And remember the first one was this network function virtualization. We took a router and we virtualized it. Right? Our virtual router just happens to be the 5600. That's what that name represents. But it's since we virtualized the router, this is kind of cool. We could have taken a router and virtualized it years ago, right? I mean, it's difficult, but it's not that difficult. But what happens is you get really poor performance, and with the advent of a lot of the chipsets that are out there, right, 8-core, 16-core processors on these little chips, now I can get really good performance. In fact, I can get performance that's good enough where if I take a dedicated hardware platform and I virtualize it and put it on a virtual machine and I run it, I can get better performance than a lot of the hardware that's out there, right? So these little virtual routers start to become very, very powerful. One, because you can scale. If I want to fire one up, it's literally a drop down in the menu and say, just give me another router and put it over here. Off it goes, right? You need two? No problem. Just keep firing them up, right? We can link them together and create bigger and fatter data pipes just by adding more virtual routers. The other piece is the automation behind it. Right? So we can have IPsec functionality, we can have firewall functionality, and you can get it wherever you want in the world. You don't have to put it on a cart or on a FedEx truck and ship it overseas. You just launch a VM and put this thing on there. This software that we're showing you over there automates this process. It's the ability to say, you know what, I need a virtual router, and off it goes. Right? You don't have to do a lot of steps behind it. That's what that demonstration is talking about, moving flows and creating these virtual elements. On the bottom, this cloud bursting. So cloud was a big buzzword. I guess, last year, right? It's finally starting to mature a little bit. Every year there's some new buzzword. SDN, I think, is the buzzword this year. Last year may have been cloud. But here's what happens. We take a forward operating base and a CONUS data center. So we're in a forward operating base, and we have people that are trying to get to services that are maintained inside that forward operating base, right? They have a bunch of trucks put together, they create a little data center, and the guys are getting their email, they're doing waypoints, maps, whatever they do, right? At some point, though, you're going to run out of resources within that data center if you get more requests coming in. We have a piece of software that monitors this. So this whole thing is automated. There's no commands except get the go button. It monitors those number of connections, and if it sees it needs more resources, it will tell, in this case we're using VMware, right? It will tell vCenter to, hey, please provision more virtual machines. Give me more stuff. I need more stuff, right? At Christmas time, Amazon, they pay attention to this kind of thing, right? They add more resources as the data comes up, and then after Christmas, they pull them back down. Same kind of thing, right? We're bringing this stuff up, we're monitoring it, and then we're load balancing across it, right? If I add more resources, I don't want to just saturate the first one and not use the other ones. I want to start load balancing across all those evenly, right? So we're going to show you that process. That's cloud bursting within the data center. But here's what happens. Because it's a forward operating base, they don't have a lot of resources. So at some point, we need to burst to CONUS here. Right? I need to get to the Pentagon. I need to get to some other data center, DISA, CDC, something like that, right? We will do the same process and moderate and move and load balance that between the forward operating base and the larger data center. That's cloud burst, and it could be between here, Amazon Web Services, GovCloud. It could be a lot of different places. The concept is the same. We're showing you how to take virtualized functions, move data around between clouds, right? But here's what's unique about this. Inside that, so that's the first part of the demo, and everybody goes, oh, okay, yeah, cloud. But then here's what happens. We interject an event. If I'm in a forward operating base and an embassy gets attacked or something like that happens, a lot of information needs to get to exchange back to CONUS, right? All of a sudden, an event occurs, a commander's intent, to use buzzword bingo for the government, a commander's intent, meaning a commander that makes decisions on, hey, does this guy in the forward operating base go over the hill with his guys and attack somebody? I don't know. Give me a Predator video feed. Give me a Global Hawk. Let me know what's going on. Give me intel. All that information needs to get sent back, but guess what happens? If I'm in a forward operating base, my pipe is really, really small. So something's got to get out of the way. We have an application that's monitoring that, and when it sees that congestion, guess what it does? It uses SDN to take the lower priority data, the stuff that was already running, and we move it up to a satellite link to free up the bandwidth for the commander's intent, in this case a video feed, right? And it's all automated. This whole thing is automated. So it allows you to manipulate the movement of data based on not necessarily quality of service, but priority. Make sense? Cool. Right. So what do we got left? Secure data transfer. Okay, here we go. This one's kind of cool. This is the first one. When you first walk into the demonstration area, you see all these tablets, and you see a wind-up phone, right? The old school wind-up phones that the Marines would use, they still use, right? Here's what happens. All of those devices use call managers in the field, right? They have somebody that maintains the ability to communicate between it. We use these virtual routers to secure that information. So what we're going to do is we're going to show you the ability to connect standard phones, tablets, all the way down to this cranky thing that's got the spool of wire behind it that looks like it's from 1912, and it might be, I don't know, but those things are all out there, and we're linking them all together using sophisticated things like IPsec or TLS to do these secure encryption requirements, and we've virtualized all those functions, right? So you no longer have to have dedicated hardware. You can put this stuff on virtual machines and move them around, and that's what this demo is. It's pretty cool. You get a chance to play with all the phones and do things, right? So that's a nice little demo. The data congestion mitigation, this is a tactical piece. So let's take an example. When the plane went down in France, right? It was in the middle of the mountains there, and you couldn't get there, right? This is a bad deal. So the FBI, those guys, they get a go team, and they fly them out there, and they launch these little tactical cases to gather information, right? Video, data, mapping, whatever it is. And there's limited storage, there's limited resources out there. And you want to make sure that the link back to, the FAA or NTSB, whoever it is, that it's secured. So what we've done is we've mimicked that whole thing. We have a tactical case that's collecting information. We've used virtual routers and virtual encryption pieces to link it back to the mothership on the other side. And then at some point, congestion occurs. Well, we want to automate this. If congestion occurs, the last thing you want is somebody that's supposed to be out there doing their job to support lots of different things to have to worry about troubleshooting the network. So what happens is we've automated the ability to adjust the quality of service, to change those types of pieces of information that need to be tweaked to get the correct information to the correct people. Again, this is an automated way to remove data congestion in a tactical environment. That's what this one is. Any questions on this one? Okay, cool. And then the last one. So this is a SpectraLink demo. This is one of the ones we got from corporate. And the idea behind this is I want to be able to create secure layer 2 tunnels. So that's a technical term. But here's what happens. If I want to communicate with somebody in the field, right? If I want to communicate with you, maybe I'm allowed, maybe I'm not allowed, right? If I'm allowed, then I'm supposed to be able to communicate. If I'm not, I might be a hacker. So somebody has to figure out this process, right? So with SpectraLink Scout software and our virtual router, what happens is you go out to an authenticative, kind of an authority, and you collect search, and you make sure that the guy that's requesting the information is actually supposed to get the information, right? So you authenticate, and everybody holds these credentials, and now you're able to communicate. And then everybody does that. And then at some point, a guy in the middle is collecting who can talk to whom, and he's building this table of this mesh of network communications. And we're securing all this communication, right? So this allows, once you're kind of in the club, right, then you can talk to anybody else that's in the club. That's what this is showing. But the cool thing about this SpectraLink Scout and virtual router integration is that we proxy the information so that nobody knows who's talking to whom unless you are that person, meaning you can't sniff the information. It's all behind a proxy, right? I'm able to kind of mask who's talking to who, which gives me either lawful intercept, I can monitor it and nobody's looking, right? Or I can just keep the other people out because they really can't find me. There's no geolocation data. There's none of the other information that people normally use to figure out who you are and what you're doing. It's all based on stuff that's hidden under the hood. And we've created this mesh that allows people to talk but not be really monitored to see what they're doing. Right? It's kind of a cool demo. Any questions? I know we ran through those pretty quick. Oh, half an hour. Cool. I was told to get you out of here a little early for lunch. Anybody have any questions? Okay, great. I appreciate your time. If you do get a chance, please stop by the Pavilion and check it out. And I thank you for your time.